Now we are going to discuss behavior of the light when it will incident on the lenses. So what going to be happen? Let us see. So for full analysis, we are going to consider here four situations. By that, we are analyzing when the light fall on the lens. What going to be happen when the light fall on the lens? So here, so situation one. So in the situation one, we are considering a ray passing along the principal axis. So what going to be happen? So we will represent that with a diagram. So here it is a convex lens. So this is principal axis which passes through to center of curvature. So this is optic center P. So if a ray follows along the principal axis, so after refraction it will not deviate. So it is undeviated ray. So it will give a straight line. It is undeviated. Next consider here concave lens. So here also we are drawing the principal axis. So here also it will meet the two centers. Okay, so if you observe the difference is nothing but here for convex lens, right side we are having C1 and left side we are having C2. So for this right side we are having C2 and left side we are having C1. Just remember this. Okay, so here also if a ray follows along the principal axis after refraction also it will not deviate. It is a undeviated ray. Next we are going for situation 2, the ray passing through the optic center. So the ray which is passing through the optic center, it will also a undeviated ray. So that we are going to represent by ray diagram. So this is convex lens. So this is the principal axis. Okay, so here, so the ray, the incident ray is passing through this optic center. So if we observe, so this ray is undeviated. So similarly consider here concave lens. So this represents a principal axis. So this is C1 and this is C2. So this is optic center. So the ray which is passing through this optic center is an undeviated ray. Next we go for situation 3. In the situation 3 we are considering the rays which are traveling in parallel with the principal axis. So here, so this is a convex lens. So this is the principal axis. So this is a C2. This is C1. So these are the rays in parallel with the principal axis. So this is a principal axis. So here all the refracted rays will converge at a particular point. So that particular point we call it as focus. Okay, so next here, so I am drawing, so this is for concave lens. So here also this is a principal axis. So this is C2, this is C1. So these are the parallel rays. So which will fall on the concave lens. All the rays are after refraction. Those are diverging in nature. So if we extend back of the diverged rays, all those will meet at a common point. So this common point is called as focus. This common point is called as here focus. So here next we go for situation 4. So the ray passing through focus, the ray which is passing through focus will take path parallel to the principal axis. We are already studied this is in mirrors also. Okay, so that is nothing but here consider. So this is a convex lens. So this is the principal axis. So this is center of the curvature. Okay, so this is a focus. So what is saying? The lines, the rays which are passing through focus, which are passing through focus. So after refraction, they will take path which is parallel to the principal axis. So this is principal axis. So after refraction, so these all rays will parallel to the principal axis. Next we draw for this concave lens. So this is a concave lens. So this is a principal axis. So here, so this is a center C1 and this is C2. So this is a F2 and this is F1. So here, so the rays which are towards your focus, all will after refraction will choose the parallel path to the principal axis. Okay, so here so these are the incident rays. Okay, so this incident rays is towards this focus. So after refraction, so these rays will choose a path which is in parallel with the principal axis. Next here, so one special case is there. If some rays will fall on the lenses, making an angle with principal axis. So what happens? Let us see. So this is a convex lens. So this is principal axis. Okay. So here some rays are coming like this, making an angle to the principal axis. So this is principal axis. So the rays are coming like this. That is nothing but these rays are making an angle with principal axis. So here, so this is center. Okay, so this is the center C1. So this is the focus F1. Okay, so here this is focus F2. So what happens here? So when the rays which are fall on the convex lens converge at a point in focal plane, will in focal plane. So all are converged at a point. So which are in the focal plane. So focal plane is nothing but here. So the vertical, if a vertical line is drawn like this, so that converged point is on this vertical line only. So that is called here focal plane. If we draw the same diagram for this concave lens, okay. So this is principal axis. So here some rays are coming like this, such that those are making some angle with the principal axis. So these are the incident rays which fall on the concave lens. So here these are diverged like this. Okay, so here if we extend, so this will if we extend this, so all these will meet at a common point. So which will be on the focal plane only. So here, so in order to draw the ray diagrams, okay, so we must know these four situations. So if we understand these four situations clearly, we can easily draw the ray diagrams for this convex lens as well as concave lens.